Okay, so for transformations of logarithms, this A affects the y values. C affects the x values. So don't forget this means either right or left, okay? And this means up or down, depending on D being positive or negative. So the B value does not affect transformations at all. Okay. So the B value does not affect transformations. The B value, what it does is it shows you, or is how long it takes, okay, for the y value to reach 1. Okay, so this will you'll always be as the B value comma 1. And I'll explain what that means as I go over the examples. The C value tells you where the vertical, so this has to do with the asymptote, the vertical asymptote is. So you'll see this as x equals c. If you set this equal to 0 and solve for c, you just add c to it. So then that tells you where the asymptote is going to be located. So notice, if this is plus, then the asymptote moves to the left. If this is minus, then the asymptote moves to the right, depending on the value of c. Okay, so that's what this is saying. So I'm going to start with the transformations. Notice this is log base 2, but we're just trying to understand how this graph gets transformed in comparison to the parent function. So this minus 4 means the graph goes to the right 4 units. And that plus 20 means up 20 units. And that's all for this one. Okay. Number 2, you have a 1/4 in front of the log, so that means the value of A is 1/4. So what this is going to do is going to create a vertical shrink by 1/4, which means we multiply all the y values by 1/4 when we graph. And that's the only transformation for number 2. For number 3, this only has a plus 20, so that means up 20 units. And that's the only transformation to number 3. Number 4, you have a negative, so that's going to create a reflection. So the graph gets reflected over the x-axis. And the 3 creates a vertical stretch by 3. And then the plus 9 is going to translate the graph to the left 9 units. Over examples number 5 through 10 on how to graph the functions below. So this is base 10. So I'm going to copy the table that you just got on the pink paper or the pink notes. And the table that you have there is x is 1/10 or 1/10, x is 1, and x is 10. So then when x is 1/10, that means y is negative 1. When x is 1, y is 0. When x is 10, y is 1. Okay? So then this, the only transformation this one has is that it's going to go up 2 units. That's the only transformation. So up 2, which means from the origin, let's move the graph up 2 units. So this is up 1 and 2. So we're going from this point now. So notice I am not plotting the point. I'm using the plus sign. So then once you do the plus sign, along with the plus sign, sketch the asymptote so that when you graph, you don't get past this line. Because this, the negative values for x are not defined, are not in the domain. Okay, they're in the range, but not, for y, but not in the domain. So from here, if I go 1/10, then I need to go down 1. So it's going to be hugging the asymptote. If I go right 1, no up or down. That means 0 up or down. If I go right 10, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up 1. And when I connect the points, this is what the graph looks like. So notice it can approach the asymptote, but it cannot cross the asymptote. It cannot even touch the asymptote, okay, on the graph. So that's number 5. Then let's go to example number 6. So for this one, the transformations are that minus 2 means the graph goes to the right 2 units, and this plus 1, the graph goes up 1 unit. Okay, so those are the transformations. So from the origin, let's go right 1, 2, and up 1. So now the plus sign is here. Along with the plus sign, the asymptote. So the asymptote is here. So this is what it meant. The asymptote, the equation of it is the value of C. In this case, C is positive 2. Okay. All right. So then, since there is nothing in front of the log, that means A is 1. We can follow this table again. So from this point, if I go right 1/10, which is very barely noticeable, down 1. Right 1, no up or down. That means 0. If I go right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I'm guesstimating here, up 1. And then connect the points. Example number 7. So for this one, this 2 is going to create a vertical stretch by 2. And then that minus 5 is going to take the graph down 5 units. Okay, so let's do the translation down first. So from the origin, go down 1, 2, 3, 4, and 5. So this is where we're going from now. Now notice that the printer or the copier didn't, I don't know, for some reason it cut off the rest of this grid. So then once you plot the plus sign, just make sure you sketch the asymptote before you do the points. And anyways, we have to change the values for y on the table. Okay, so I'm going to copy this table here from parent function. So we have x and y. This is 1/10 for x, and then this is 1 for x, and then this is 10. So y is negative 1 here, it's 0 here when x is 1, and it's 1 when x is 10. So then now take the y values and multiply them by that 2. So 2 times the y values. 2 times 1 is negative 1 is negative 2. 2 times 0 is 0, and 2 times 1 is 2. Okay, so then I'm going to cross out this column. From here, so if I go right 1/10, which is somewhere here, I have to go down 2. So let's say this is 1 and this is 2. So that point is barely noticeable. You can't really tell, but the next one you should be able to tell. So if I go right 1 from this point, then no up or down. If I go right 10, so this is 2, 3, 4, 5, 6, 7, 8, 9, 10, up 1. Actually 2, right? This should be up 2. So let me correct that. So this is up 2. Then connect the points. And this is the graph of number 7. Let's go on to example number 8. Okay, so for number 8, I have a negative in front of the log. So that means a is negative 1. So this will create a reflection. So the graph gets reflected or reflect over the x-axis. And then that plus 5 translates the graph left 5 units. Okay, so that's a 5, not an S. So let me make that more clear. So left 5 units. So from the origin, let's go left 1, 2, 3, 4, 5. So we're going from here now. Also, sketch the asymptote. So this is where the asymptote is located. Notice in this case, C is negative 5, or C is equal to negative 5. Okay. Now, what I need to do is I need to copy this table and then change the sign of the y values. So I'm going to copy the parent function table. So again, x is 1/10, x is 1, x is 10, -1 for y, 0 for y, and 1 for y. Then all we have to do is, given that we have a negative, in front of the log, change the sign of the y value. So this becomes +1, 0, -1. Okay, then I'm crossing out this column. So from this point, if I go right 1/10, now I'm going up 1. If I go right 1, no up or down for y. If I go right 10, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, down 1. Then connect the points. And this is the graph of example number 8. Go on to number 9. So for example number 9, we have a 1/2 in front of the log, so that means a is equal to 1/2. So this will create a vertical shrink by 1/2. And then the +4 is going to translate the graph to the left 4 units. Okay, so let's do that transformation. From the origin, go left 1, 2, 3, and 4. So now we're going from this point. And then sketch the vertical asymptote. Now, I need to change the table, so I'm going to copy the parent function table again. And then I have to multiply the y values by 1/2. So xy, 1/10, 1 and 10. -1 for y, 0 for y, and 1 for y. So now let's take half of each one of the y values. So then this is -1/2 or -0.5. This will still be 0, and this is +1/2. Okay, so then I'm crossing out that column. Okay, so from this point, if I go to the right 1/10, which again is barely noticeable, if at all, down 1/2, so about right there. Right 1, no up or down. Right 10, so this is 2, 3, 4, 5, 6, 7, 8, 9, 10, up 1/2. And then connect the points. And there is the graph of that function. Okay.